Welcome back to lesson 15.2. In the previous lesson you looked at the registers inside the processor and how they work together in the fetch execute cycle. Now let's look at the buses that are used to connect the different parts of the processor. In this lesson we'll look at the difference between serial and parallel transmission, and we'll see the work of the control bus, the data bus and the address bus. The locations and registers of the processor will store several bits of data. This will vary between 8 and 64 bits, but in any case it's multiple bits. Let's imagine we wanted to transmit the data from one location to another. If we use serial transmission, the bits will flow one after the other. The bits come down one stream and fill the different locations one after the other. Parallel transmission operates more quickly. There are 8 or more connections, and so all the bits can be sent at the same time. If it's a 64-bit word, then 64 bits will be sent at the same time. This means the channels are somewhat wider and take up slightly more space, but the transmission is much quicker. Buses are conductive channels which connect the parts of the processor. They're short, very fast connections that use parallel transmission. The width of the bus is equivalent to the word size of the computer. There are 3 types of bus. They all send binary numbers, but the binary numbers stand for different things. The 3 types of bus are the control bus, the data bus and the address bus. You can probably tell from their names what they do, but let's quickly go through that. The control bus sends control signals from the control unit to all the other parts of the computer. It's a two-way connection because the parts of the computer can also send signals back to the control unit. For example, ready to store. The clock signals, which we've also heard about, are sent down the control bus, and these are used to synchronize the different parts of the computer so they all operate together. The data bus is also a two-way connection, and we've seen in the previous presentation how data is sent between the processor and RAM. Data will also be sent from input devices into the processor and from the processor out to the output devices. So there are data buses throughout the processor and they operate in both directions. Control and data buses work in both directions. The address bus is a one-way signal. It goes from the processor to RAM. During the fetch part of the fetch execute cycle, it sends the address to fetch from, and during the store part of the fetch execute cycle, it sends the address to save to. In practice, these 3 types of bus are bundled together into a single channel called the system bus. If you look closely at the system bus, you'd see it had 3 parts. The system bus goes right through the processor and connects to all the different parts of the processor. Can you see in this picture that the data and control buses have two-way connections, but the address bus has a one-way connection only? So to recap, buses use parallel transmission. There are 3 types of bus: the control bus, the data bus and the address bus, and they're bundled together into a channel called the system bus that goes right through the processor. So I'm leaving you with an exercise. Make sure you've got notes on buses. If you've got time, your extension activity is to draw the system bus and I'm setting you the challenge of creating an animation to show the difference between serial and parallel transmission. In the final part of this week's work, we'll look at 2 further registers, so I'll see you in the next lesson. Bye for now.